Okay, so hello everyone and welcome to this presentation of our MAISE project. My name is Jose Cano. I'm a lecturer at the University of Glasgow and the PI of the project. This project is hosted at the University of Glasgow, and we have two main partners, ST Microelectronics and also SIGSA Scotland. And in addition to myself, the rest of the team is composed by Jeremy Singer and Silon Tio, which are academics at the University of Glasgow, for him, Ayas, who is a postdoc at the University of Glasgow too, and finally Danilo Po, who is technical director at ST Microelectronics. So I'm going to introduce the project answering a few questions. And the first one is, what is multimodal AI-based security? So let me split this question in two halves. In the first half, we have multimodal AI, which is basically a new approach for AI where we combine different types of data like images, text, or speech, and also different algorithms. So the objective in putting in these different parts together is to provide a more performant system, okay, more accurate system, an AI system with more performance. On the other hand, we have AI security, which is essentially using tools and techniques based on AI to provide security, or in this case, cybersecurity. So the objective here is to detect and also to, react against against attacks, cybersecurity attacks. Okay, so our project basically is composed of these two parts. The second question is, what is the edge, or what is edge computing? Well, edge computing means to move the computation from the cloud to the end of the internet, or close to the end. Depends on the project or on the application. Okay. So then edge computing devices range from small, tiny microcontrollers that can be attached to sensors to big systems like driverless cars or satellites, things like that. Okay. Well, so we have now the background. So what is the key question we want to answer in this project is, okay, how to secure, optimize, and deploy AI models or AI applications on constrained edge devices, but without trading off the accuracy, right? This is a very important part. So in order to answer this question, in this project, we have three main objectives. The first one is to provide co-optimization of AI inference models. And this means to essentially satisfy specific deployability constraints on edge IoT devices like memory or compute capacity, but also being able to be robust against different types of adversarial attacks. And I'll give you a couple of examples in the next slide. The second objective is to provide continuous and secure deployment of this co-optimized model, okay, on the IoT devices. And this means that we need to update the model with new data, with labeled data, and thus optimize and re-optimize and retrain the model and deploy it into the edge devices, right? And finally, the final objective is to demonstrate this flow, okay, on specific case studies. In our project, we consider audio and images separate, and then we put both together in a global system. Okay, so let me give you some more details about the first 2 points. So for the co-optimization of DNNs, let's assume that we have a set of neural networks that are able to provide voice recognition and facial recognition, and well, we are able to optimize these models with well-known techniques like NAS, neural architecture search, or HPO, hyperparameter optimization. We can also use quantization or dequantization. Okay, so applying these techniques, we can obtain very optimized models that can satisfy the constraints of specific IoT devices. Well, we have a lot of experience, and there are many people working on this area, right? The problem now is that we can have a set of adversarial attacks that essentially can compromise the accuracy or the performance of our models, okay, of our neural networks. So what we want to do in this project is to essentially consider these attacks, for example, neural exploitation or adversarial perturbation, and include them in the optimization stage, right? So we need to co-optimize the models with these types of attacks, right? And in the end, provide a model that is resilient or robust to both. So in addition to that, given a few examples of attacks, we can also generate more examples of these adversarial attacks. How? We have thought to use GANs, generative adversarial networks, in order to provide more and more examples, and then, retrain and validate our optimized model with these examples in order to increase the robustness of the system, right? And as you can imagine, this process needs to be continuous. So we have a loop here where we keep updating and optimizing and deploying the model. Okay, that's the first step. Let's assume that we have our model optimized in the cloud, and next what we do is to deploy these models on edge devices, right? And the key point here is that these edge devices are able to generate new examples, new valid inputs. Okay, so we need to include these new inputs in the model, but also new adversarial examples. Okay, so we need to provide those and, as I mentioned before, optimize this model. As you can imagine, once we send this information to the cloud, the model needs to come back to the edge, right? And this back and forth process needs to be secure, essentially, right? For achieving such a security, we want to leverage our previous experience with chameleon hashing and also key management service, and in the end, provide a secure and robust deployment at the edge. Okay, so this is basically the structure of the project. Let me now talk a little bit about impact in general, and I pass the word to my colleague Danilo that will focus a little more on the industry part. So essentially, this co-optimization space, to the best of our knowledge, is new. Okay, nobody has addressed this co-optimization space in advance before. Okay, and this makes the project highly relevant to both academia and industry. And for the part of industry, Danilo, I leave it to you. Well, there are a few things that we want to achieve. So yeah, go ahead.
Yes. First of all, it's of paramount importance to develop end-to-end frameworks in the field of artificial intelligence, because first of all, the industry is missing such a comprehensive approach because it impacts deeply the productivity. Today, most of the approaches are completely handcrafted, even if there are tools that partially automate the steps. Secondly, deployability, which means capability to effectively map the solution on microcontroller and resource-constrained device, which are also low power, has to be taken since the beginning, even before or even during the conception phase of the AI solution. So these are two factors very, very, very important. Giuseppe?
Yeah, thank you, Danilo. So this is the impact from the industry. Obviously, from the academic point of view, essentially our target is to generate top-tier publications, right, in top-tier venues, to serve as a starting point for future or further research. Okay. Also, a second point is basically engage with other academic institutions, and events like this one are, I think, that are intended to that, and also to the broader community in general. Okay. So yeah, this is more or less the overview of the project. So I don't know if we have some time for questions, but we are happy to answer any questions you can have. Thank you.